Good day to you, my dear friends. I have a very early stream. It's 5 in the morning here, because today I won't be able to stream anything later. But if I have a goal to stream every day, that's my only opportunity. And boy, do I have something to show you. Wait a second. So yesterday we started this problem, counting bits. We are given an integer and we want to return an array. And every element of this array, it shows us a number of ones in a binary representation of each number from 0 to our integer. And yesterday no, don't look at this yet. Yeah, that was my solution from yesterday. Let's check it. Of course, we do not need offset. So we have, let's say, 5. If we have 5, then counting from 0 we have 6 elements. So 6 times we take an element, convert it to a binary representation, and we count ones, and we put the result in this array of answers. And immediately what I can fix here is this, because we do not have to use to split our string into separate characters, into array of separate characters. We can just use count directly on our string. I hope so, at least. Let's try this. Yes. Now let's go to a solutions section. And this is a solution. I looked at it yesterday and I wasn't able to understand anything. Of course, I could just use the same formula, but my goal is to get better at this, to get a better understanding. So I refused to move forward without understanding where this formula came from. And let me try to open IRB. Because I was able to understand this formula, and I'll try to explain it to you right now. Let me try to show you my IRB console. Looks crazy. Nope. Yeah, it doesn't work with terminal window. No, let's remove it. Maybe we have some Ruby online. Yeah. Great. Let's check for enter its binary form. Come on. No. Okay. Do you see it? Yes. You can see it. So a binary representation of 4 is 100. Let's also see a binary representation of 8. It's 100 and 1 more 0. And what about 16? The same. We take the previous value and we just add a 0. So we can say that we left shifted our previous value. Why does it even work like this? Well, the same thing happens when we use every system, not just binary. Let's say we use decimal system and we have a 52. But let's multiply 52 by 10, and of course we will get 520. Again, we took this previous number 52 and we shifted it to the left, and we added 10 to the right. And this is actually true for every system. Let's take how do we call it, hexadecimal. Let's say we have 2. And we are going to convert 2 to a hexadecimal number. And also you want to try 32, because it's 2 multiplied by 16, 2 times 16. Let's see. And again, the second number is just the first number left shifted by 1 position. And the same is true for binary as well. What does it mean? That every even number in decimal system, like 6, it will have the same number of ones as 3. And this is the truth for every even number. We just have to know how much ones we have in this number divided by 2. But what about odd numbers? Okay, let's say we have an 8 here. What about 9? Well, of course, it's a binary system, so a representation of 9 would be a representation of 8 plus 1. So if 8 was converted to 1000, then 9 will be 1001. So in order to get number of ones in odd number like 9, we need to get number of ones in 8 and just add 1. Let's remove all that. So we can say for 8 it's gonna be the same number of ones as for 4, and for 9 it's going to be the same as for 4 plus 1 for 9. How can we say it differently? It would be 8 divided by 2 to get 4, right? Convert it into binary. And here we can make it like 9 minus 1, right, and this, and then plus 1 here. But luckily for us, in Ruby division works like this. Eight divided by 2 is the same thing as 9 divided by 2. Because of the way Ruby does it, it's rounding. It always rounds to the lower number. So for example, 5 divided by 6 is going to be equal to 0, and even 11 divided by 6 is going to be equal to 1, not to 2. What does it mean for us? That we don't have to do minus 1 here. We can just divide 9 by 2, and this is it. And if it's not an 8 or a 9, it's I, as in my example. You see, it's I. Obviously, it's going to be something like I divided by 2 That's for even number. And for odd number, the same thing, +1. And if we go to the solution, that's what represents it. Soon we'll get to why it use counts. We have another solution here. Well, none of the solutions explain how we use this formula, how do we get to this formula. Here let's say we have an array of results with one element, 0. And here we have a range, well, not a range, oh yes. It's 1, and many other things, and to the, say, to 5. And for every number, we check if it is even or not. And we start with 1. 1 is an odd number. So for 1, we want to take, well, 1 has the same number of ones as 1 divided by 2 and +1 using our formula. And 1 divided by 2 is 0. But can we take this 0? How do we know that we have 0? Well, let's take our results array and let's take 0 element from results. Now, what's very convenient is that number 0 also has 0 ones. Even like that. And when we know that number 1 in its binary form has just 1, 1, 1, we put this result in our results array, like this. So when we get to number 2, we use the same formula. But because it's an even number, we do not have to add 1. We just need to do this, because 2 has the same number of ones as 2 divided by 2 in binary form. So it's going to be 1 again, and we add these two results. So in our results array, we always have a number of ones for element I divided by 2. I mean, when we get to element 4, we already have in our result array a number of ones in element 2, because we started from 0 and we built upon it. And you see this guy here. He checks if number is even or odd, and he adds 1 or nothing. But the first guy, he was more inventive than that. He used this thing. So in order to understand if this is an odd number or an even number, yes, it's Ruby. I know, I'm a pervert, sorry. So we divide it with a remainder by 2. And if it's an even number, we'll have 0. If it's an odd number, we'll have 1. How many LeetCode problems? I don't know, like 200 maybe, but I did them, in a lazy way. The moment I solved it, I moved forward without too much thinking. Now I try to dive deeper into this problem. And why? Well, for 2 reasons: to get a better understanding and to get a job, probably. So that's why. But let's get back to this problem. So this guy, he has an array counts. Well, I was a software engineer before I got laid off, as so many people. And I need a new job, so I'm trying to prepare myself for the interviews. Oh yeah. And it's not... Well, I'm doing this in Ruby because I work in Ruby. That's my working language. But Ruby is nice, maybe it's not very popular right now. Well, maybe they don't know Ruby, but they should. You don't have to know the language, you just have to understand the logic of a solution. I mean, the solutions, they are probably the same in every language, well, for the most part, with little small variations. So this guy, he uses counts array, and he iterates through this array with map method. And notice that he used map with a bang. Map with a bang. And this bang, it returns, well, it changes counts on the go. So when we hear address counts, it's not a number anymore from this range, it's the count of ones in its binary representation. Well, the same thing for Ruby. It has so many methods to solve pretty much anything. In my solution, I did not use range. I used times, so I do not have an array to go back to. That's why I use the approach from this guy. I start with an array with just one element, 0. and we can add a condition here that we only do that if I is more than 0. And here we also want to use this formula. But it's not a result, in our case it's ends. And it's not 1, it's I, remainder 2. Something like this. Yeah, it's working. What can we also do? We can abandon this check if we just use n here, not n plus 1. But here everywhere we want to use not I, but I plus 1. I believe we are going to get the same result. So this is the answer. And let's go back to the solutions. And not in C, of course, but in Ruby. Now this guy, he creates this array counts, and he converts range into an array, and it's already a big O of n operation. And I don't do that, so I do not waste time to do this, but I waste time to do this if check for every element, so it's also big O of n. Or if I do not use if and I just adds 1 to everything, still it's big O of n operation. So if you win some time here, you're going to lose it in some other place. So we can just use a solution by this guy. Only in description we have to create an array that is called like this, and that would be a final solution. Yeah. Well, it's 5 in the morning, so I'm very confused and distracted. Great. And let me show you a problem from yesterday. Maybe this one. Yeah. I told you let's not use this map method, because map method in Ruby, it returns a new array. And why do we want to create a new array? We can just return this one. So I went back to my previous solution, but actually we can use map, but like in our previous problem we have to use map with a bang. Yeah, this counting bits problem that we just solved, well, it's beautiful. it's what makes you love programming. Look at this. Jesus. Okay, now I don't know if I have time to solve something else today. Let's see. What we got. Somewhere at page number 4. It's a tree problem. Probably it'll take some time. 3, 2, 5, 6. Good. Children. Okay. I think we had something similar to this problem. It's called result. Children. Maybe we can just map. I don't know. Oh, I started to do this in JavaScript all of a sudden. Let's see. Oh. Result. Oh. Yeah. It's called child. No. No. So, of course we want to do this. Great. Come on. Now. Okay, this is it. It's good for now. I'm so sleepy that I have to stop right now. Not just because I'm sleepy, but because it's time for me to go. Thank you very much, my dear friends. I'll see you tomorrow. And that's all for now.